Hi and welcome back to Gaffy's Grinds. This is the Leaving Cert Chemistry edition. In these videos, we'll be taking some concepts from Leaving Cert Chemistry, we'll be breaking them down, we'll be trying to help you understand them, real simple steps, and then giving you some practice to do. This is video 8 of our organic chemistry series videos. This is going to be a quick one. It's a little bit of a sidestep, but it's something we need to recap before we talk about how crude oil is separated. Crude oil is separated using a process called fractional distillation, and we need to recap simple distillation from your junior cycle before we jump in so that you understand the basics of what's involved. Quick reminders: if you've got anything that's going to distract you, your phone, or you've got other tabs on your computer open, you need to close them now. And really important, obviously, I say it every time, but if you need to do the questions when I ask you to do them, if you don't, you're just not going to learn anything from these videos. So I just want to talk about, we've seen now that crude oil is a mixture of substances, and we've already recapped what a mixture is. And if we think back to our junior cert of when we had a mixture, we learned about some separating techniques. These are techniques that we can use to separate different types of mixtures. Now, I want to talk about a specific kind of mixture here. So, say, for example, we have a container with a mixture in it. So we've got a container, and in the container, we've got a mixture of liquids. Oh, I don't want that to happen. There we go. We've got a mixture of liquids. Okay. Now, how is the mixture of liquids? How are they different from each other? So let's say we've got 3 liquids in here. Okay. How are they different from each other? Well, they're different because they have different boiling points. So we've got three different liquids. So say we've got one that evaporates at 100 degrees C. That's its boiling point. It turns to a gas at 100 degrees C. So in the last video, we recapped boiling points. So the boiling point is the temperature at which a substance turns from a liquid to a gas. So say we've got one liquid in here that boils at 100, and we've got a different liquid that has a boiling point of, say, 70 degrees C. And finally, we've got a third liquid that has a boiling point of, we'll say, 50 degrees C. Now, of course, this substance contains 3 different liquids. It is not a pure substance. These 3 substances are obviously different because they have different boiling points. So they're definitely not the same stuff. So we call this type of liquid, or this group of 3 substances here, we call it a mixture. What is the definition of a mixture? Okay, so I want you to speak your answer to the screen now. 1, 2, 3. Okay, so a mixture is 2 or more substances that are together, but they're not chemically combined. So in this case, we've got 2 or more, we've got 3 liquids, and they are together, but they are not chemically combined. Okay, now, so a mixture this time is of liquids. Sorry, I want that to fix itself. Liquids with different boiling points. Well, what do we know about these? Well, we know if we were to take this mixture and we were to heat it up, what's going to happen here? Well, this one is going to evaporate first. Now, why is it going to, how do we know that it's going to evaporate first? Well, we know it's going to evaporate first because the first temperature out of these 3, 50, 70, 100, obviously the first temperature that we're going to reach out of those 3 is 50 because it's the lowest. So when we get to 50, all the particles in here that have a boiling point of 50 are going to evaporate, they're going to boil, and leave behind just the mixture of the 2 liquids that have a boiling point of 70 and 100, because they won't be ready to boil yet. So they won't be boiling until we reach their boiling points. Obviously, that means that this one, with the highest boiling point of 100, this is going to evaporate last. And that is the general gist of distillation. It'll separate this type of a mixture. If you can think back, if you can name any other separating techniques that we can use to separate different mixtures, I want you to say them to the screen now. 1, 2, 3. I'll give you a minute because there's a few. Okay, just a quick recap. Okay, we can have filtration. Filtration can separate a substance which is insoluble, so a solid which does not dissolve, from a liquid, so something like sand from water. We can pour the mixture into the filter paper, and the sand, because it is not dissolved, the particles are still quite big because it's a giant substance and there are many atoms in there. On many particles in each grain of sand. They're too big to fit through the pores or the holes in the filter paper, so the sand gets stuck, but the water gets through. This would not work for something like salt and water, because salt dissolves and all the ions are pulled apart when we dissolve them, which means you've got tiny individual particles or tiny little ions. These are tiny, these are microscopic, and they will fit through the pores of the filter paper. So the whole lot's just going to go through the filter paper, water and the dissolved salt. So filter paper no good for that. Also no good for this mixture of 3 liquids. They're all liquids. There's nothing solid. There's no big particles get stuck in the filter paper. So it's not going to work for 3 liquids because they are all mixed together. They all dissolved in each other. So not going to work for that. Other separating technique, which I might have mentioned, would be evaporation. That would be similar to this kind of thing here. Okay, evaporation. But it's different to the thing we're going to see today, distillation, because distillation allows us to it allows us to separate 2 liquids or 2 things with different boiling points, but it allows us to collect both. It allows us to collect both or all 3 liquids, however many there are, we can collect them all. Whereas evaporation, we usually heat off the one with the lower boiling point and we lose it. So something like salt and water, we can heat it up. Salt has a very high boiling point, ionic substance, so it's not going to boil for thousands of degrees, but the water is going to boil at 100 degrees and it will evaporate off and leave behind the sand, or the salt, sorry, leave behind the salt. Problem is, again, you can't keep the liquid, you can't keep the solvent. So it's kind of like distillation, but well, what we're going to see today, but again, it's just not as useful. Other separating techniques involve chromatography, separating colored substances. We will see that again in more detail. Also, we can use a magnet. So if you've got a mixture of things and one is magnetic and one is non-magnetic, you can use a magnet to separate them out. So that's just a general recap. Okay. Well, let's look today at distillation. So how would we take this mixture that we've talked about here already, the 3 liquids with the different boiling points, and separate it so that we can keep the different liquids? Well, you might recognize this. This is the apparatus that we would use to do a distillation. What I'm going to get you to do now is, before I label it, what I'm going to get you to do is I'm going to get you to pause the video and I'm going to get you to draw down. This is the apparatus for a simple distillation. Okay, so pause it and draw the apparatus down for me. Okay, so you should be playing the video if you've paused and tried to draw, and you've drawn out the apparatus for simple distillation. So make sure you've got a heading, apparatus for simple distillation. And what I'm going to get you to do now is pause the video and try and label as much of it as you can. Okay, so you should have paused the video and you should have tried to label as much as you can. What I'm going to do now is I want to talk you through the different parts and help you label it. Okay. Now, the idea here, and this is the most important bit, is I'm going to take a colored pen. This is the most important thing, is what's in here. Before we start labeling the equipment, what is in here? Well, this is obviously our mixture. This is what we're trying to separate. Mixture. Now, what type of a mixture is it? It's a mixture of liquids or substances with different boiling points. Sometimes there might be 2 liquids, sometimes it might be a liquid and a solid, sometimes it might be 2 liquids and a solid, sometimes it might be 5 different liquids, sometimes it might be 100 different liquids. Okay, but the key thing is it's a mixture of liquids with different boiling points. And like, you could have 100 liquids and every single one of them could have a different boiling point. Okay. You might get a very odd substance that has the exact same boiling point as another substance, but it's quite rare actually. You're generally going to have substances that are going to be at least slightly different by 1 or 2 degrees, but many substances are different by 20, hundreds, thousands of degrees. Okay, but that's the key thing, is that's what's in here, the mixture. So you could have one liquid that has a boiling point of, I'm going to take an example that we're going to do below. Okay, the example we're going to do below here, as you see, the questions below are going to be about trying to separate a mixture of ethanol and water by simple distillation. So let's use that as an example so you get to see it in advance. So we have one liquid which is 78 degrees Celsius is the boiling point, and that is ethanol. Ethanol. So we'll draw those particles in red here. The ethanol particles are red, and then we have a second substance in here which has a boiling point of 100 degrees C, and that is the water. And those are shown as blue particles here. Okay, those are shown as blue particles. Now, for labeling the rest of the equipment, okay. Well, in the beginning, what are we going to need? Well, we're going to need a tripod. This is a stand that we can heat things over. That's a tripod. So this is this stand here with 2 legs. They normally have 3, but when we're drawing a diagram, we generally tend to show 2 of them. So we're talking about 2D, okay? This here shows a heat source of some description. So what we're talking about here is usually a Bunsen burner. Bunsen burner. And above the Bunsen burner, we generally tend to have a wire gauze. It's like a little sheet of metal gauze, and what it does is it spreads the heat out evenly. Okay, so that's what we're going to use for heating. A wire gauze on top of a tripod and a Bunsen burner underneath, which will be heating. What about the glassware? So most of the rest of this is glassware. Well, this here is called a round bottomed flask. It's a type of flask we do a lot of heating in. Sorry, that's only one, so just flask, not flasks. Okay. And we're obviously going to put our mixture in here and we're going to heat it. Now, this is an important piece of equipment here. The thermometer helps us to measure the temperature. Why would we need to know the temperature in this? Well, we need to know when a liquid starts to boil. And when we reach the boiling point of a specific substance, we need to know that information. Okay, at the top of the round bottom flask here is a tube that leaves the side of it. We call this an arm. And then attached to that is this piece of equipment here. And this is called a condenser. This is a condenser. Okay, now what the condenser does is it cools down the substance again. So what's going to happen here is when we heat the liquid, or when we heat the mixture here, eventually we're going to get to a temperature of 78 degrees. Not a lot's going to happen until we get to 78 degrees. And then when we hit 78 degrees, the ethanol is going to start to boil because we have reached its boiling point. And what's going to happen at that point is the ethanol particles are going to evaporate. They're going to spread and they're going to move up towards the top of the flask. When they get to the top of the flask, then they're going to enter the arm and they're going to move into the condenser. There's still gas particles at this stage, but because we have reached 78. So they're at 78, or even, yeah, they're at 78 degrees to turn into a vapor. Now, the thing about the condenser is it's got cold water flowing in at the bottom and cold water flowing out at the top. And this sleeve here, so this bit here, all of this is filled with cold water. Not the inside tube. They do not mix. The inside tube is where the ethanol vapor is, and the ethanol gas is. The cold water just makes a sleeve around the outside. So it's a tube inside a tube, basically. Okay. And the cold water keeps the tube really cool. So what that's going to do is this ethanol, which has reached 78 degrees, when it goes up and into the condenser arm, it's hitting this cold surface. That means energy moves from these particles and goes into the cold water, which is going to reduce the temperature of the ethanol particles. And when we reduce the temperature of the ethanol particles, they go back below their boiling point. So when they've gone back below their boiling point, this has turned them back into a liquid. And what happens then is they flow down the condenser and they collect over here in what we call the distillate. So this here is the distillate. The distillate is usually collected in a beaker or some kind of a container. So we've got a beaker of distillate. This is the substance which has been through the distillation process. What you might also hear this called is a fraction. It is a fraction of what we started with. It doesn't contain all the particles that we started with. If it did, it would be a whole, but it's a fraction of what we started with. Okay. Now, if we had more than two substances here, say, what we could do is, once we reach 78, we could collect all of the distillate. We would then see the temperature would keep going, so we could then remove the beaker, and when we get to the temperature of the next boiling point, the substance that's going to boil next, we could put a new beaker underneath and collect it as it boils. Okay, and so on. So if you had 5 different substances here, you could have a different beaker and collect each different substance at its boiling point when it starts to boil. Okay, and each one would be called a fraction. A fraction. Now that's going to be important in the next bit, next video that we go into, a fraction. It's the distillate. Okay, time to do some practice now. So these questions are about trying to separate a mixture of ethanol and water by simple distillation. Ethanol has a boiling point of 78 degrees and water has a boiling point of 100 degrees. So I'm going to get you to pause the video now and try to do them 5 questions. Okay, so you should only be watching the video if you have paused and had a good go at doing them 5 questions. Okay, making sure that you write in full sentences like I always ask you to do. So again, if you didn't, I should have reminded you that before you started. Pause the video and make full sentences of your answers. Okay, so we should be playing now if we've done the questions and we've done them in full sentences as best we can. All right, let's have a look at the answers now. These are the answers coming up. Okay, so pause the video and make any corrections that you need to make. Okay, that was a quick video. It was just a recap on simple distillation. Okay, if you have any questions, make sure to ask me about them in class tomorrow or whenever I see you again. Okay, and I hope you found this useful. It is just a recap, but it's important for us to build into a more complicated type of distillation where we're dealing with crude oil, which has loads and loads and loads of liquids with different boiling points and loads of hydrocarbons with different boiling points. But it's the same basic idea of how it works. It's just going to be more complicated because it obviously involves a much bigger scale and many, many liquids with different boiling points that need to be separated. Okay, so I shall chat to you in the next video. I hope you found that useful.